So my presentation is going to be on harnessing Earth observations to tackle climate, environmental, and food security challenges in Africa. So I'll be referring to some of the work that we have done that is utilizing Earth observations data to address some of the challenges that Africa is facing with regards to climate, environment, and food security. As we know that SANSA is the custodian for the country's space data, and its mandate is basically to just promote the use of space to change the lives of the ordinary South Africans. So basically, my talk is more on going to be the use of Earth observation / remote sensing data for us to be able to address some of the challenges that are under these themes that I've listed on my title. So basically, this is just an introduction, an outline of what I'm going to be talking about. I'm going to be introducing some of the issues that are relating to climate, environment, and water, as well as food security in Africa. And then I'll try and relate those to how those are actually interrelated and link them together, and also look at how then the Earth observations data supports the improvement or the solutions that are actually hoping to improve or trying to solve the problems that are resulting from the challenges that Africa is facing. And I'm also going to be looking at some of the Earth observation applications and tools that we've developed from the South African National Space Agency. And I would also look at the challenges that we are facing and probably some of the way forward. And hopefully out of this presentation, would have gotten some of the partners that we probably need that would allow us to be able to take the use of Earth observation to the next level with regards to solving the problems that are relating to climate change, environmental crisis, and amongst other things. So in my introduction, basically Africa is faced with multiple crises, which are sort of like resulting from the rising food. One of those challenges basically is the rise in food insecurity, which has led to over 280 million people being undernourished. So what is happening is that some of these food insecurities are as a result of the fact that the agriculture sector is highly vulnerable to droughts and erratic rainfalls, which is therefore causing crop failures, which results in less yields that are produced within the countries in Africa, therefore causing some rising on fruit prices and market disruptions, which therefore results to the undermining of the livelihoods of the people that are living within the region. In addition to that, we also have challenges that are as a result of intensified climate impacts. We know that Africa contributes the least to global emissions, but it suffers disproportionately to some of the global emissions that are there. So some of the impacts that we get from these global emissions would be more frequent droughts and floods, as well as heat waves, which then causes some challenges with regards to food security and environmental impacts and other things. And also, there's also some shifting rainfalls, which therefore threatens the traditional farming systems within the area, which also contributes to crop failures, rising food prices, amongst other challenges that we are facing with regards to these themes that I've listed. The other challenge that Africa is also facing is the rapid environmental degradation, which speaks more to the deforestation, desertification, soil erosions, and loss of biodiversity, which is sort of like accelerating or increasing at a very rapid rate. And as a result, now there has been some reports that are basically saying that the land is over 65% of Africa's land has actually been degraded. And as a result, now some of the productive land has been lost within the region, which therefore contributes to some of the challenges that we are facing in Africa that are relating to environmental, climate, and other things that I've listed in my previous slide. And as a result, now we therefore need timely solutions that are going to be addressing these challenges at large spatial extent. And for us to be able to do that, we need accurate data that would then inform those solutions that we are actually going to be coming out with, that are going to be addressing the issues that we are facing in Africa. However, what we are noting is that in Africa, there's a lack of ground-based data, because in most cases, some of this data data comes in ground, is measured in ground stations. However, what you would notice is that in many African regions, some of the areas are not actually equipped with tools and technologies that allows us to be able to get good insights and good data on some of these changes that we are having. As a result of this lack of data, then we are having challenges with the focusing of some of the risks that are associated with these environmental changes, climate changes, and other things. And also some of the decisions that we take based on the data that we have would be fragmented because we don't have good distribution of the data that is actually giving us a good or a clear indication of what is going on with regards to changes in climate, amongst other things. And also some of the policies that are derived from this data, we know that policies, for them to be effective, they need to be supported by scientific data. And as a result, if we don't have good distribution of data, then the policies that we even come with are actually going to be fragmented, because what we are going to be having is the data that is not complete, and therefore which then means that the policies that we are going to derive are actually going to inform certain areas than the others, because, or favor certain areas than the others where the data is limited. And we know that if there's no, the policies are fragmented, then that means that in every situation where we are facing issues of climate change, we would not be able to respond on time because we don't have enough data to inform us on what are some of areas that are experiencing these challenges, and where can we then target the interventions to those areas, and what sort of interventions do we need to get into that. So with lack of data, then we are unable to come up with those scientific sound solutions that are addressing the challenges that we are facing. And as a result, now the role of Earth observation, basically it allows us to be able to support the actions in all these areas at different scales. So when I'm talking more on Earth observations, I'm talking about more on the data that is collected by the satellites that are in the outer space, which gives us information about what is going on within our Earth. And those are actually allowing us to be able to track the changes much better than using the traditional field measured data. Because with field measured data, in as much as it gives us a good understanding of what is going on the ground surface, but it is limited to certain areas. So with satellite technologies and Earth observations data, we are then able to monitor every area concurrently and over large spatial extent and improve scales, and therefore increasing our understanding of what is going on with regards to climate change, what is going on with regards to environmental degradation and food security. And therefore that allows us to be able to get a good time series monitoring of these aspects or indicators that are relating to the challenges that we are facing within Africa. So for example, if we are taking the use of traditional field data, of course, it can give us some of the input information that we need. However, with regards to long-term monitoring of such, then it becomes challenging, because what we are noticing is that in Africa, we've got quite a lot of developing countries, and as a result, we don't have enough resources for us to be able to continuously monitor this phenomenon. So that is where now the Earth observation data comes in, because now it allows us to be able to continuously monitor these systems and these indicators that are relating to these challenges. And as a result, now we are able to establish patterns that would allow us to be able to decide on what needs to be done to address the challenges that we are having. And as a result, with all those patterns, then we can have projects that are supporting the implementation and evaluation of some of the key solutions that we are proposing based on these patterns that we've actually identified. So basically, the role of Earth observation in decision making, as I've indicated, that we are basically using satellite data, and we've got different products, satellite data that are ranging from that have been collected from different years to current, which are sort of like give us a continued monitoring of the changes in the environment. So the table that you see, it basically gives us some of the satellite products that we host here at the South African National Space space agents, which we have data for, which allows us to be able to develop these systems that allow us to be able to track environmental changes, climate changes, amongst other. So with all this data, we are then able to experience to sort of like monitor wide coverages. So basically what you would notice also with the traditional approaches is that when you go into some areas might not even be accessible. For example, if you want to go and monitor in areas that are very remote, it becomes difficult for some of for people to reach. And as a result, now with Earth observation, we can then pick up those areas, and then we can pick the changes that we've observed by analyzing the imagery that we are going to get from these products that we are having in-house. And also frequent monitoring is actually feasible with the Earth observations data. So what we are having, or what we are basically looking at, we are saying that it becomes much easier for us to be able to say what has been the change over time, over frequently, because this data provides us with satellite imagery that are collected on repeated coverages. And as a result, now there's a way that it becomes easier for us to then continuously monitor this. And some of these satellites, basically, they are free and open access. And as a result, now we are able to leverage on them to be able to improve the decision-making process for that are relating to agriculture, climate change, food security, amongst other things. So those are some of the benefits that we are having. So we are actually going to present some of the value chain that we have, which is a famous slide that I've presented to you. So how does this data gets collected? So what happens is we get the satellites. Satellites are orbiting the Earth, and they are capturing good snapshots of imagery, which are then transformed to us in form of the spectral signals that we then use to relate to some of the phenomenons that we have. For example, some of the phenomenons that we'll be looking at would be looking at changes in environmental conditions. If we talk about water levels, if we talk about water qualities, we can then use some of the indicators that we can pick up from those images for us to be able to get now the changes, or to monitor the changes over time. Then we then take those imageries then to process them into machine learning, deep learning models to come up with products that are then going to inform policies, agencies, that are going to inform land and water managers' decisions with regards to issues relating to climate change, issues relating to food security, amongst other things. So this is basically the value chain. What you would probably look into this or get out of this is basically we collect imagery, and then we transform it to true models that we run, and then they bring us outputs that are sort of like time series monitorings of these critical indicators that are telling us more about these issues that we are having. And then we then use those to be able to inform the decisions that the land water managers, resources and policies that we are having, that are guarding the protection and management of our environment and our food systems within Africa and in our country. And then some of the tools that we have, basically, that we have for that are relating more to climate change. So here at SANSA, basically, we've developed some of the tools based on these Earth observations products that we have. Some of the tools that you see in front of you basically allows us to be able to monitor gases within the atmosphere and concentration and the movement of those gases. So basically, we use such data for us to be able to build onto these systems so that we can be able to see what is how is the concentration of different gases within the atmosphere, and how are they getting dispersed within the atmosphere, and how does that informs the climate change and other things, so that then we can be able to put in targeted interventions and look at what are some of the solutions that we can put in place for us to be able to manage those. And the other indicators that we use, or the data we use for, we can use Earth observation to monitor water resources. For example, this is some of the product that we have in-house that is monitoring the dam levels and the changes in the water extent within our surface water resources in the country. So if you are looking at the image, it then shows that there has been some pattern of changes from 2018 to 2021, and which corresponds to some of the drought conditions that were experienced, particularly in the Western Cape between the period of 2016 and 2021. So if you are looking at the changes, it then shows that you can be able to pick up some of the changes, and then from then we can then say what are some of the interventions that we can then take into consideration to improve the conditions that we are having in the country. The other tool we use also this data to be able to inform agricultural decisions. So for example, we've got now the in-house tools that allows us to be able to monitor the cropping extent, the crop health, the irrigation planning to predict crop anomalies. Those are some of the important features that allows us to be able to predict some of the anomalies that would see in our agricultural cropland fields. And those would, because we know that if there are certain anomalies, then that threatens our food security. And as a result now, if we are able to pick it up early, then it becomes easier for us to be able to target the interventions that to be able to know exactly also where we can put in the interventions with regards to that. So these are some of the tools that we are having. And also we have some irrigation tools, which also give us an indication of when and where to irrigate, because at the end of the day we have water crisis, and then we don't want to over irrigate also, which threatens also the yields that we are going to get out of these fields. So we need to have that data that will tell us where do we irrigate at what time. So we have these tools that are based on the earth observations data that are able to tell us about all those conditions, and as a result we are able to inform the decisions with regards to where is the area that has crops that are highly at risk of diseases, where do we irrigate, and what sort of interventions do we need to put. Like for example, if we say that we want to put nutrients onto the soil, where should we put them, and how do we, at what level, at the concentrations, in terms of the concentrations, do we put those nutrients, and where do we target those interventions where we see those crop anomalies. So we have all those tools that we have that are doing that. And also we have some disaster management tools that is actually informing our disaster preparedness and responses. So what we are having here is one of the work that we did that looks into the recent flooding that has occurred in the Mthatha area, which has led to many lives being lost. So we were able to then map the extent of the flooding. So if you are looking at the blue, that actually shows the areas that were managed to model out for the flooding based on the earth observations on the right picture. And then the areas, the red circled areas are basically the areas that were flooded during the occurrence of the flooding. So that actually tells us that earth observation does give us good insights of the risk of areas at risk that would occur during the flooding events that can that are happening in the areas. So we are able to inform government in terms of which are the more areas that are more vulnerable to flooding, so that there can be targeted interventions. For example, in the event that they have to move people to new places that are less risk in terms of flooding, then that can then be implemented. And also we have another picture there that shows some of the work that we did for the Kuwabata at the Amatole district, where we were actually looking at the flood extents and looking at how it actually impacts the settlements that are around the area. And we are working closely with those government departments to inform them about some of these findings. And then what they do is they then take decisions based on what we are providing with them, which are based on the earth observations data. And also we have some rules. So we have some systems that we have in house that is monitoring the land use and land cover, and also land use planning. So we have the settlements layer that we've just concluded, which actually shows the distribution of settlements within the country. And I've selected one local municipality, and then where we are just monitoring the spatial extent of the settlements that you see there. So what happens is that we also be able to track some of the settlements that that are threatening our biodiversity and resources. For example, we just published a paper last year that is actually looking into trying to see how has been the change in terms of the informal settlements within the Western Cape during the COVID times, because that now we notice that there has been some growing or sprouting in the informal settlements within the area, which threatens the key priority biodiversity areas like your fynbos, like your wetlands, amongst others. So we were able to build those models to predict the changes so that we can be able to see when has been the settlements, where and which areas are at high risk of those settlements, and how do they then impact the key priority areas within our country with regards to biodiversity. And then these are also some of the tools that we have, which monitor different water quality parameters, which monitors water changes, water levels, extents, amongst other, in different areas. So we are able to use Earth observations data to actually come up with all these key aspects that we are looking into for actionable solutions that are sort of like informed by the science that is behind our research. And also some of the key challenges, in though we are able to use Earth observations to be able to do all these things, but we are still facing with challenges because we are relying more on the satellite data. The satellite outputs then needs to be validated. So the limited ground truth data, therefore, it somehow sort of like creates challenges in regards to validating our systems and models that we are having that are based on Earth observations data. And as a result, now we are unable to then say or make conclusive decisions that this actually a true representation because there's limited data. However, we are trying to work with other institutions that are dealing more with collection of ground stations measured data to be able to assist us with that data so that we can improve the spatial modeling of these challenges that we are having. And also, we have technical capacities, which is one of the key things that we are still struggling with, where we have less capacity and more work that still needs to be done within the Earth observation space. And also some of the infrastructural challenges with most of the data that we are having will require quite a good storage. So now we constantly need to expand on the storage as new data becomes available. So we need systems that would then allow us to be able to store all this data that we are having and then process it into useful products that would allow us to be able to better inform the solutions that are actually addressing the challenges that Africa is facing with regards to climate change and environment. And also, we are having issues of misalignment between data products and users' needs. So we are somehow trying to build this network of users where we are trying to understand exactly what is it that they require, that and what is it that we can then remote sense out of the requirements that we are having. Sometimes the misalignments between what they require and what we are having currently is presenting some challenges because we find out that some of the data that we have cannot necessarily solve some of the problems that we have. And then the last one will probably be funding, which is something that all the institutions lately are actually facing, and also institutional coordination, like coming together and working together to build these systems that allow us to be able to better inform the thing. And then as a result now, we've proposed some way forwards based on some of this noted things that we have while we are building these systems and engaging the other users. We probably need to co-design these tools. So which means that they need to speak directly to the farmers' needs and policymakers. And then we also need to invest in ground data collection. In as much as EO provides or offer prospects for us to be able to get these good insights. However, one of the key issues that we are having, we do need data to validate that. And Earth observation cannot compensate for ground controlled data. So we need to sort of like find a way in which we can then collect this data and then match these two types of data for us to be able to get a better improved systems and at a less cost. And also, we need to build the local capacity for us to be able to train people, because now there's technologies, there's AI that is coming up, which we are trying to adopt. And as a result, now we need to sort of like build capacity on that. Then there's a need for trainings on these cloud tools that allow us to be able to build these systems that we are trying to have. And then we have to institutionalize this EO use in policy frameworks. So, for example, if we are talking about water resource management policies, then we probably need to somehow include Earth observation data as a complementary information that needs to form to be that is needed to be able to formulate these policy frameworks, because it allows us to be able to monitor these water resources that we are having. And then we also need to leverage on this for early warning systems. Currently, we are building decision support tools that would allow us to be able to provide early warning systems for different environmental, climatic, and food security challenges that we are having in the country. And now we have some of them that are in the phases of being complete, not necessarily complete, but being up there and then being consumed by the public. But we are still trying to get more people to become involved, to bring their data and expertise so that we can then improve that better. Thank you so much.